Reconstructing dynamic 4D human avatars usually requires expensive multi-camera arrays. 4DAnyone solves this by generating high-fidelity, multi-view consistent videos from a single, uncalibrated monocular video. These generated views are then lifted into 4D Gaussian Splatting. This approach democratizes 4D content creation, allowing anyone to build realistic dynamic avatars using just a smartphone camera. Existing video diffusion models struggle to maintain consistency across the dozens of views needed for 4D reconstruction. This failure stems from a bounded attention context in diffusion transformers. When target views exceed memory limits, they must be split into independent groups. This causes two issues: growing reference context overhead and cross-group structural drift. To control viewpoints accurately, 4DAnyone uses sparse 3D skeletons instead of unreliable dense depth. The system renders these skeletons using a pixel-wise Z-buffer. This depth buffering resolves front-back pose ambiguities, such as whether an arm is in front of or behind the torso. This ensures geometrically consistent guidance across all generated viewpoints. As more views are generated, conditioning on all of them becomes computationally expensive. Reference context packing, or RCP, solves this by compressing the growing set of reference views into a fixed-length, mixed-resolution context. This reduces the reference context complexity from linear growth to a constant O1 overhead, preserving appearance details efficiently. To prevent independent view groups from drifting apart, target context routing, or TCR, dynamically rotates view groupings during the denoising process. At high noise steps, views are cyclically regrouped to share global structural information. At low noise steps, groupings are fixed to stabilize local details, ensuring seamless transitions across all generated angles. 4DAnyone outperforms existing methods in both video quality and downstream 4D Gaussian splatting reconstruction. It generalizes robustly to challenging in the wild videos, complex human motions, and diverse clothing. Quantitative tests on DNA rendering and DIMV humans benchmarks show significant improvements in multi-view consistency and reconstruction accuracy. Despite its success, 4DAnyone has limitations. It struggles with loose, flowing garments that move independently of the body skeleton. Additionally, errors in the initial 3D pose estimation can propagate to the final generated views. Future work will focus on integrating physics-based clothing simulation and improving pose estimation robustness.